Hi there. This video covers the ideal gas law. So to solve these types of questions, you'll need a few things. You'll need to know that STP stands for standard temperature and pressure, and standard temperature is 0 degrees. Standard pressure is 1 atmosphere. Temperature always needs to be in Kelvin. So if you have Celsius, you got to convert it to Kelvin by adding 273. One thing about the ideal gas law is the units are very specific. You need to have liters. So here's the milliliters liters conversion if you need that. And it's also specific about the unit for pressure. And you need atmospheres for the R value that we're using for the version of the ideal gas law we're using. We want atmospheres. So if you have any of the other things, you can convert it into atmospheres using that conversion. This right here is the ideal gas law, PVNRT, PV equals nRT. You will need to know that equation. There are two equations I will not give you on the test. One is the ideal gas law, and the other is Dalton's law, which we talked about in a previous video. The ideal gas law has some more variables, and those variables need to be in specific units for this all to work. Pressure, for the version of ideal gas law we're using, pressure needs to be in atmospheres. If it's not, you need to convert it into atmospheres. Volume needs to be in liters. And again, if it's not, you need to convert it into liters. N in PV equals nRT, N stands for moles. Now, one variation of the types of questions you're going to see is, I might not give you moles, I might give you grams. And you would have to convert grams into moles, which we've done dozens of times in this class. So if you ever see grams, know that, okay, well that's related to moles. So R stands for the ideal gas constant. And R is always, for the version of this law that we're using, R is always 0.0821. And then the unit for R is this big mess back here. And I'll talk about that once we do an example here. And then, just like all the other gas laws, temperature's got to be in Kelvin. Some little hints here on how to write or how to solve these types of problems, but I'm just going to jump right in and do a couple examples. So first example, whoa, that's not what I wanted, that's from the last video. There we go. This first example, what is the volume of 6.3 moles of gas at STP? Well, I know this is a PV equals nRT question because it's got moles. Once I see moles, I know it's PV equals nRT. All the other equations we use, none of them have moles. Also, I'm looking for one volume. I've got moles, and I've got a temperature and pressure. I only get one of everything. I don't have like a starting and ending. So that's another tip, that it's not like the previous gas laws we talked about, but it's instead PV equals nRT. So it says, what is the volume? So I'm looking for volume. So first thing I'm going to do is I'm going to rearrange for volume. I'm going to divide each side by P. So I get V equals nRT divided by P. Now I got to figure out what all these things are. Well, N stands for number of moles, and that's given to me right in the question, 6.3 moles. So 6.3 moles. Again, if I was given grams, what I'd have to do is I'd have to use the periodic table and convert grams into moles so that I have N, which is number of moles. I also need R, and like I said, R is always this number with that unit right there. So 0.0821 liters times atmospheres on top, Kelvin times mole on the bottom. And what else do I need? I need temperature and pressure. And now some people might read this question and be like, well, it doesn't have a temperature and pressure, but it does. When I say STP, that means standard temperature and pressure. And if I look up here, standard temperature is 0 degrees Celsius. So I got my temperature is 0 degrees Celsius, which I need in Kelvin, which is easy. Just add 273 to 0. And I also need pressure. And my pressure is 1 atmosphere. And that is in the correct unit. So I didn't have to do any converting there. So I know all my variables. I know N, I plug it in there. I know R, I plug it in there. T goes there, P goes there, and I solve. So N is 6.3 moles times R, which is 0.0821 liters times atmospheres divided by K times mole times T, which is 273 Kelvin. I'm going to divide all of that by pressure, which is 1 atmosphere. That'll make the math kind of easy. So, put in my calculator, I do 6.3 times 0.0821 times 273 divided by 1, which I don't really have to do. If I look at my sig figs, now I really only have one number that's given. I got 2 sig figs. So my calculator says 141.203 blah blah blah. Well, I want 2 sig figs, so 140. Now let's look at the units. The reason R has this messy unit here, L times atmosphere divided by K times mole, is to cancel everything that needs to be canceled and leave whatever's left. So if I look here, I got mole and mole, they cancel. K and K, they cancel. Atmospheres, atmospheres, they cancel. The only unit I have left here is liters. So that must be the unit for my answer. So I have 140 liters. And that makes sense because it asked what is the volume. So it makes sense that I'd have liters for my unit. Fairly straightforward. I'll do another example here. I should have enough time to do that. So next example. What is the temperature of 5.7 moles of gas at 1500 mmHg in a 750 milliliter container? Now I might move this up just so I have even more room. There we go. So again, I'm looking for temperature. I've got moles, I've got pressure, I've got volume, I have one of each. Again, a sign that is going to be PV equals nRT. In this case, it says what is the temperature, so I'm looking for temperature. So I want to get temperature alone. To do that, I divide by N and R. I can divide by 2 things, that's okay. Some people are weirded out by that. Well, those N's cancel, those R's cancel. I'm left with an equation as T equals PV over NR. Now it's got to figure out what all those things are. Well, the first one, pressure. Pressure is given right here, 1500 mmHg. If you remember, I said that the ideal gas law is very specific in the units it uses. So I'm going to go back up here and I can see that, well, pressure needs to be in atmospheres. Right there. Pressure must be in atmospheres. So I'm going to use this and I'm going to do some converting. That's my starting number times blank line, starting unit on the bottom, mmHg. What I'm looking for on top, ATM. 760, that's a 6, there we go. 760 mmHg equals 1 atmosphere, so 1 atmosphere. I do that math. 1500 divided by 760, and with 2 sig figs I get 1.97. That keeps going. But that's going to be equal to 2 sig figs, because 1500 has 2 sig figs. That's going to be 2.0 atmospheres. The next variable I need is volume. And I look at my question, and I have a volume. It's right there, 750 milliliters. But again, that is the wrong unit. I need to have liters. Well, to go from milliliters to liters, I just move the decimal point over 3 places. Or you could do a conversion, just like we did with the pressure. And I gave you the conversion up at the top here. 1 liter equals 1,000 milliliters. So that's what I used here. And that gives me 0.75 liters. Okay, so I'm making some progress here. I've got my pressure, I got my volume, I got N, which is number of moles. Yep, that's right here. So N equals 5.7 moles. And the last thing I need is R, and R is always the same number. R is always that number right there. 0.0821 liters times atmospheres over mole times K, or K times mole. It doesn't really matter the order there. So I've got all my variables. I can plug them into my equation here. Oops. That's going to equal pressure, which is 2.0 atmospheres, times volume, which is 0.75 liters, and divide all that by N, which is 5.7 moles, times 0.0821 liters atmospheres over mole K. So I'm going to do the top math, get an answer, do the bottom math, get an answer, divide the two, or use parentheses. Don't put it all in at once without parentheses. It will give you the wrong answer. 2.0 times 0.75 is 1.5. So 1.5 divided by, well, let's do this, 5.7 times 0.0821. I get that answer, and then top answer divided by bottom answer. So 1.5 divided, 1.5 divided by 0.46797 gives me 3.20 blah blah blah. I want 2 sig figs, because I got 2 sig figs there, 2 sig figs there, 2 sig figs there. I get an answer of 3.2. And if I look at my units, atmospheres cancel, liters cancel, moles cancel. The only thing left is K. So K, 3.2 Kelvin is my answer. Pretty much out of time. So those are the 2 examples. There will be questions like this on the practice quiz. If you get stuck on those, you don't understand what you're doing, stop by. I got paper versions of all the practice quizzes, so if you want to do a paper version instead, you can do that. Just stop by on one of our off days. Talk to you later.